Okay, assalamu alaikum wa rahmatullah. Good afternoon for you all. Today is our fourth class in the subject of database application development. So yesterday we started the database design chapter, and we have gone through many things. Actually, we learned how to describe the design phases and how to explain how to construct the entity relationship diagram, and we are still here in this point. So today we are going to complete this point, and we continue to the transform from entity relationship diagram into relations. So yesterday we stopped somewhere here. Okay. Yesterday we talked the difference between the relationship type and the entity relationship instances. For today, we are going to continue with the degree of the relationship. So here for the degree of the relationship is the number of entity types that participate in the relation. So if the relation is between or involving only one table, then this relation is considered unary. Unary means only one table is involved in the relationship. Binary means two tables. Ternary means multiple tables more than two. So 3, 4, 5, 6 tables are still ternary. Okay, so this is the depth or the degree of the relationship. So here I will give you some examples to understand. If let's say we have one table here, and the relation is between the table and itself, like that, the table and itself, like this. So this one is called unary relation, because this relation is involving only one table. But if let's say the relation is involving two tables, like this, two tables like that, and maybe the relation is one to one or one to many or many to many, we don't care about it. But once it involves one table, two table, this is called binary relation. Why? Because it involves one and two tables. So for more than two tables, any relation involves more than two tables, it's going to be considered as ternary. Okay, ternary relationship. So that's all about it. It's very basic idea, very basic concept. We just need to remember it only. Okay. Uh, okay. Let us see the slide here. Let us see the slide. Please, guys, don't unmute yourselves. Somebody of you makes a lot of noise. Okay, now is okay. Okay, in this slide here, we can see that the relationship, the degree of the relationship is as I explained. So here at the left side, we have the unary relationship, which involves only one table, and here we have the binary relationship that involves two tables, and the other side, at the right hand side, we have a relation that involves three tables or even more. Then this relation is considered ternary. Okay. Any question in this regard before I move on?
Not for now, doctor.
Okay. Then now we come to something called cardinality, cardinality of the relationship. So the cardinality of the relationship, I have already explained some examples before about the one-to-many relation and many-to-many relation, but one-to-one relation I did not give any example before. However, today I'm going to explain these three types of relations in more detail, inshallah. So the first cardinality is one-to-one. So each entity in the relation will have exactly one related entity. So if let's say uh, I'm not going to use the screen annotation because it makes me a lot of headache. So I'm going to use the paint to draw whatever. So here, if let's say we have one table here and another table here, and the relation is like this, 1 to 1. Okay, so this dashes, this dash and this dash means 1 to 1. Okay, so in this case here, for every row here, for every row here, we should have only one row at the other side. So if this row is for Ali, this row is also for Ali. Okay, so that's why it's considered 1 to 1. So we cannot have multiple records for the same record from the left side, or multiple records here at the left side related to one record at the right side. This case is wrong. Okay, that's why we have to have only one record in each side related to the same entity. That's why they call it 1 to 1. Okay, later we will take some examples to understand more. The other cardinality is the one-to-many. So one-to-many means an entity on one side of the relation can have many related entities at the other side, but an entity on the other side will have a maximum of one related entity. Okay, so what does it mean? This, if let's say this side is many and this side is one, so that means if let's say here, I will give you an example. If let's say this one is order, and order number 10, for example, and here, for example, the order items. Okay, so here the order here at the right side, the order number 10 will have only one record. It will never be able to have more than one record related to this order number. Okay, but at the other side, at the left side, we may have multiple records. Maybe this one is 10, this one is also 10, this one is 10, and this one is item number 1, item number 2, item number 3, like this. Okay, so here, what do we have here? We have multiple records from one side related to only one record at the other side. So this side will have only maximum one record, maximum one record related to the same entity. Okay, the same instance of entity. Okay, for the other side, it could have, depends on our design. There is something called one to many. One or many. There is another type called zero and many. So it's up to you. This is a very advanced thing that we are going to learn later. But for now, I'm not going to cover. Here, in this case, in this side, we could have more than one record related to the same entity instance. Okay, so that means we could have more than one item related to the order number 10, or more than one item related to order number 9, and so on. Is this clear, guys? Okay, good.
Yes.
Okay. What's about the many-to-many? Many-to-many is that the entities on both sides of the relation can have many related entities on the other side. Okay? So here, let us clean this. If let's say we have two tables here, okay, and this is the relation many-to-many. So that means maybe this record number 10 will have multiple records for 10. Okay, maybe I need to draw this to clean this first. Oops, this is very slow. Okay, in this case here, we could have one record at the right side. The relation is here. I am going to draw it at the top here to get space. So if we have, for example, number 10 at the right side, the whatever record that has an ID number 10 at the right side here, it could have multiple records on the left side with the same details or related to the same entity. And also, we may have something with ID number 20 that could have multiple records at the right side. So this is what they call it many-to-many. Okay, so here we may have many records that have many records on the other side. Okay, so I don't want to make it very complicated. For now, you remember it as it is, like this. Later, example by example, then you will understand how it works. The most important thing in this regard is that to build a many-to-many relation, to build a many-to-many relation, what do you have to have? You must have a middle table. You must have a middle table. So here the relation, the final relation is many-to-many, but this one is not a direct relation. This one indirect relation. So this relation is direct. So this relation could be many to one, and here many to one also, this direction, or it could be the opposite way. The many could be here, and here is one, like this. It depends on how you design and what is the scenario you want to solve. Okay, so no matter how these two relations are, the many-to-many relation must have a table at the middle. Must have a table at the middle to form this relation. Otherwise, we cannot make a many-to-many relation directly between two tables. Okay? So one more thing, I don't want you to confuse. This relation actually is not a ternary. Okay, it's not a ternary, because here this relation involves two tables, which is binary, and this relation involves two tables, which is also binary. So we don't have any ternary relation. The ternary relation could be something like this: when we have more than two tables, sorry, more than two tables like this, and they are involved in the same relation, like that. Okay, this is what they call it, ternary. Okay, so please don't confuse yourself. Okay, let us come to this slide and see. We will have some relations or some examples for the unary relation, which is if let's say we have a person and this person is a spouse of another person who is saved in the same table. So let us take an example here. If let's say this is the table of people, then here we have ID, name, and spouse ID, spouse ID. Here, this field actually is a primary key, and this field is a foreign key connected to this primary key, connected to this primary key. So the side of the primary key is always 1, and the side of the foreign key could be many. So in this case, if let's say Ali is the husband of, for example, Noor. Okay, so here if let's say Ali ID is, for example, 19, then name is Ali, then let's say here after number of records, maybe we have 251, which is Noor, and Noor here, the spouse of Noor is the ID number 19, and the spouse of Ali is the number of 251. So here we can see this is connected to here, and this one is connected to here. So that's why the relation is an internal relation between the same table and itself. Okay? Is this clear, guys?
Yes.
Yes, okay. One more thing. Is it necessary for any person to be married?
No.
It's not necessary, right? So it's optional here. That means this one person is optional to have a spouse, right?
Yes.
Optional to have spouse, and also optional to have one spouse or multiple spouse, right? If this is the case,
Yes.
if it's allowed to have multiple wives, then this is the design. So it will be 1, 2, optional many. Okay, but in many cases, especially non-Muslim countries, they don't allow to have multiple wives, right? So here in this case, the relation should be also 1 to 1, right? So one man should have maximum one wife, but this one wife is optional, right? That's why we put the O. O means optional or 0. Okay, so this is means every person could have one wife or no wife, and also every woman could have one husband or no husband. Okay, so this is the case. So in here, if let's say Ali 19 wants to key in the information of another wife, the system, because of this relation, is going to reject, because based on the design, any person is allowed to have only the entry of one spouse. Okay? Okay, guys, is that clear?
Yes.
Okay. By examples, you will understand easily, inshallah. Okay, so here in this design, they make it 1-to-1 for the person and the spouse scenario. Okay, what's about the other scenario? Employee and manager and employees who are under his control. Okay, in this case, we will have also, I will keep the same table, but instead of okay, it looks like I have to delete it. Okay, if let's say this is the table which is called employees table, then here if let's say we have the ID and here we have the name, for example, and other information, then the boss ID, for example, boss ID. So the boss ID is also an employee, right? So his information, the information of the boss, supposed to come from the same table here. So the relation here is between this field and this field. Okay, this side actually is primary, right? The ID is the primary key. So that's why the side of the primary key is always 1, and the side of the foreign key, this one is a foreign key. So this side will be either 1 or many. It's up to the design. If it's up to the scenario and the requirements of the system. So in our case, every manager could handle many employees. Okay, if this is the case, that means the relation is 1 to many. So here, if let's say we have one person called, for example, this person is 10, the name is Ali, and here we have null. Null, that means this person is a top manager. He's a top manager. He doesn't have any boss. That means he is the big boss. Okay, so if let's say we have Noor and city, maybe under the management of Ali. So in this case, maybe Noor is 51, the ID of Noor, and the ID of city maybe 63. So here, their manager is number 10, right? Their manager is number 10. So these two are connected to the same person. Okay, so the relation is 1 to many. But also, the relation actually is in this relation, it's possible to have here to make this optional, because it's not necessary to have many employees under the manager. So any manager could have employees or no employees, right? Is this the scenario or not? It depends on the policy of the company, right? It depends on the policy of the organization which requires this system. If they said there should be no manager without employees under him, in this case, we should make this mandatory. So minimum, it will force minimum 1 employee under every manager. Okay? And this side here is 1, right? But this one, is it optional or what they call it, optional or mandatory?
I think mandatory.
Mandatory.
Yeah.
So if mandatory, how we can have null here? So if mandatory, that means everybody should have manager, but the top managers doesn't have bosses, right? So in this case, this one is an optional. Okay, it depends on the scenario. That's why sometimes on the many side it become optional, sometimes on the one side it become optional, and vice versa. Okay, so it depends on the requirements of the customer. Is this scenario clear now? And how we make it optional or mandatory? Is it clear?
Yes.
Anyone have a question? No questions?
No, no.
Okay, then we should move forward. Okay, the relation, the binary relations, actually is the relations that involve two tables. Okay, so here, based on the binary relation, we have three types of relations. So the binary relation could be one-to-one, could be one-to-many, could be many-to-many. Okay? But as I said before, these two are direct relation. And this one is indirect. What does it mean indirect? It will require a table at the middle. Okay? So this table actually is only to form the relation. So in this case, here we will have a primary key 1. Sorry. Here at this side we will have primary key 1. And at this side we have primary key 2 for the table. I don't know why this closes every time. The Webex actually is not good as Zoom. Zoom is much better. Okay, primary key 1, primary key 2. Okay, so here in the middle table, we have to have at least this primary key saved here and this primary key saved here. So here it will be one-to-many, and here it will be one-to-many. Okay, so this table actually is a kind of assignment, is a kind of assigning the course to certain students and assigning the students to multiple courses. Okay, so let us take an example here. So if let's say we have Ali, which is a student with the ID 2255, for example, and we have a course called, for example, C++, with, for example, code 10, and what else, database, maybe the code is 20, and here we have for example Noor, and the code is 2356. Okay, so this is saved in one table and this one is saved in another table, right? So how the relation, the middle table of the relation will look like? So it will look something like this. So here, if let's say Ali took the C++ and the database, so it will be like this, 2255, then the code is 10, the code is 20, 2255, So this one actually is connected here, and this one is connected here. So also we have Noor. Noor talks also the same courses, so it will have 2 records here, 2, 3, 5, 6. What if we have another course, maybe data structure 30? Okay, so in this case, if let's say Noor took another course called data structure, so here Noor will have another record for the data structure, right? Is that clear, guys? Is this clear?
Yes.
Yes.
Okay, so here we have for one course, for example, course 20, we have 2 records. So one course with many students, right? With Ali and Noor. And this course is one, but has one minimum, or maybe optional to have students. Maybe we open a course and we don't have any registered students. It depends on the requirements of the university or the school. Okay, and also we have course number 10 that has also 2 records here. Okay, so the same thing here. Student Ali has 2 records related to 2 courses. That means one student with many courses, and here one course like DB with many students. Okay, so the relation is many to many. But here we need to break down the relation. Here this relation is 1, and this relation is many here. Okay, here is 1 and here is many. This one, actually we don't want to record, we don't want to save a record here without course code. So here the course side is mandatory, and also we don't want to register or save a record without student ID. So this side is also mandatory. But maybe we will have one course that has no students. So in this case, this one is optional, especially if the course is elective. So maybe we open an elective course and nobody take that course and add it to his own credit. Okay, and also here, is it possible to have a student without courses? Definitely no, right?
No.
So this one is mandatory, you see? Depends on the option, depends on the requirements. Okay, is that clear, guys?
Yes.
Okay, good.
Yes.
Any question before I move?
No.
Supposed to be no. Okay. For the one-to-one scenario, for the one-to-many actually is very clear, I think, because we have taken the scenario of the order and order lines, and also this one product and product lines. Also other scenarios we have been taken. Also this one actually, this one here is this one actually is one-to-many. So this one is one-to-many. We already have taken this example. Okay, the only example that we don't take, the example of a relation that we don't take, is one-to-one. So one-to-one actually is a very limited scenario. Very limited scenario. In very limited cases, we will require to have one-to-one table or one-to-one relation. So if let's say this is 2 tables, so if let's say the relation here is 1-to-1, so in this relation, one should be primary. One side should be the primary, and the other side should be the secondary. Okay, it's necessary. Okay, one side must be primary and the other side must be secondary. Otherwise, if let's say we cannot decide which one is primary or secondary, then both sides will have the optional annotation. Okay, so here, if this one is the primary, the secondary part is only an extension to the primary, an extension to the primary. Okay, extension is right. I forgot. Okay, the other side actually is the secondary side is an extension for the primary side. Okay, let me find one scenario for you. In many cases we have a table of people, or people like this. So the people table will have the ID, will have the name and other information. Okay, let's say this one is 10, this one is 11, 12. So Ahmad here, Ahmad, Ali, and Noor. Okay, and this is their information. Suppose that all of this are customers to our system. In our system, they are customers. And this one is the primary key. Yeah, primary key. Suppose that one of these customers, maybe Ahmed, applied to be hired in the shop. Applied to be hired in the shop. So in this case, the shop will give him access to the system, right? Will give him access to the system. So here he will have to have a username and password, right? And here is an ID. Okay, so this one actually is going to be saved like this. 10 this username and password. Okay, so in this case, Ahmed has one record here and one record here. So the relation is one to many. But which one is comes first? Which side come first? The people or the credential? Which one comes first? Which one depends on the other?
People.
The credential depends on people, right? So that means this one is primary, this one is primary, and this one is secondary, as I mentioned, right? So if this is the case, that means this one is must and this one is optional, because here we have one which is Ali who has no record at the right side, right? So Ali is available, mandatory, and at the other side we don't have a record for him. Okay, so the relation is one mandatory to one optional. Okay, is it possible to in this case to have a record here that doesn't have a record at the other side? It's not possible, right? It shouldn't be allowed. So that's why this ID actually is the primary key, but at the same time this ID should come from the other table. Okay, so that's why it's supposed to be also a foreign key. So when we have a one-to-one relation, so one side, the primary side must be primary key, the identity of the primary side must be a primary key only, and the identity of the secondary side must be a primary key and foreign key at the same time. Okay, primary key to ensure that the ID is unique, and foreign key to ensure that this value here is coming from the primary table. So if this value is not existing at the primary table, then it will not be accepted. Okay? Is that okay, guys? Nobody hear me?
Okay, Doctor.
Okay, good. Uh, okay. So for now, let me see what do we have after this. After this, we have something called ternary. So the ternary relation must have also a middle table, must have a middle table. So that middle table is used to link more than two tables in the same relation. So as you can see here, the vendor should supply parts from a certain warehouse, right? Here, the vendor will supply parts from a certain warehouse. So if, let's say, I will take this example for you, just keep in mind this shape here, and I will go to the other side to the paint, and we try to draw this. So if, let's say, this one is the warehouse table, and this is ID and name. So maybe we have warehouse 1, warehouse 2, and this one is 100, this one is 101. Okay, and suppose that we have suppliers. This one ID, suppliers, okay, and suppose that this one is ID, this one is name, for example. Suppose that this one is supplier number 1 and the other one is supplier number 2. Suppose that this one is, for example, whatever, X, Y, Z, and this one is W, K, for example. Okay, then here suppose that we have table of items or parts. So this one is the ID. So from here we can understand that the ID is mandatory, right? In every table we must have an ID. Must have an ID. It's not an optional thing. Okay, so here we may have name and whatever information. Okay, in order to link these three things, we have to have an operation or an event or whatever. So what kind of operations we are talking about? The operation that we are talking about is when the shop or the user of this system wants to order some parts from the supplier, some parts from the supplier. So here's 223344, and this one is MM, this one is WW, this one is KK. Okay, whatever. I just want to use some letters to differentiate between the things. Okay, if we want to make an order, so the order, in our order, we have to define, or we have to determine some information. The first information is the part ID, right? So part ID. This part ID is the part ID of the parts that we are running out of stock of it. Okay, so if let's say the MM is finished, so we have to order the MM. So the ID of the part is 22, right? Okay. For every part, we could have multiple suppliers. Maybe XYZ supplies this MM, and also the WK supplies the MM. So in this case, we are free to choose which one we could ask to supply this item. Okay, so suppose that we want to order that from supplier ID number 1, and the supplier ID number 1 should send this information, should send these parts to the warehouse number 100, warehouse ID 100. Okay, because the supplier should deliver these items, and when he deliver or she deliver, then they should have or should know where is the place, the address of the place they have to deliver to. Okay, so in this case, we have this ID is connected here, this ID is connected here, and this ID is connected here. So this one is 1 too many, this one is 1 too many, and this one is 1 too many. So all of this diagram is considered a ternary relationship, and this is the middle table of the relation, So here, if we want to use the annotations to represent this table of relation, so we have to use this shape. Then we have to have some, what they call it, attributes. Attribute 1, attribute 2, attribute 3, and so on. Actually, these 3 things are attributes, but in the diagram, in the entity relationship diagram, when we use this kind of shapes, we never put the primary keys. We never put the primary keys or the information that comes from the other tables, because here we have a line to the supplier, right? And we have a line to the part, right? And we have another line to the warehouse. So based on this drawing, it's definitely well known that the primary key of this file is going to be saved here, and the primary key of this file is also going to be saved here, and also the primary key of this file is going to be saved here. So no need to put any attribute for this case. Okay, but if the case is something like this, so maybe we have to record the date for the order. So here we have, for example, 2920. So in this case, we should create one attribute for the date. One attribute for the date, like this. Date. Okay, is that clear, guys? Is this clear?
Yes.
Okay, so this one is not needed. This one is not needed. If let's say we want to save other information, like for example, maybe something like time. So maybe 12 30. Okay, so in this case, what do we have to do? We have to create another attribute for the time. So our relationship diagram is going to be like this. Okay, let me make it, let me complete it. Okay, so here inside this shape we will have the order, for example, or the shipment or whatever, or the supply info or whatever. It depends on what kind of system you are designing and what kind of operation you are trying to solve. Okay, so this is what they call it, entity relationship diagram. Okay, guys, if this is clear, I'm going to move on. Is it clear?
Yeah, sure.
Okay, so for this slide, we already have taken this. Okay, I already explained this. The cardinality constraints, it's the number of instances of one entity that can or must be associated with each instance of another entity. Minimum cardinality if 0, then optional if 1 or more, then mandatory, then the maximum cardinality is the maximum number. Okay, so this is all about the dash, the extra dash that we put beside the relation type, and also the O notation that we use for the optional option. Okay, so that's all about it. I'm not going to explain anything more than that. It's very simple. I already explained it. So here in our case, in this example, cardinality constraint, we have movie is stocked as videotape. Okay, so here we have a relation of 1 to many. Okay, 1 to many, because the movie could be saved in multiple videotapes as a part 1, part 2, part 3, and so on. However, we have another, this one is actually basic relation with only maximum cardinalities showing here. Only the maximum cardinalities is shown, but the minimum cardinalities are not shown here. So in the other diagram B, mandatory minimum cardinalities is shown. So here in this side, the patient is mandatory. So at least we have one patient to have patient history. So we cannot have a patient without patient history. And also we cannot have patient history without a patient. So that's why two sides are mandatory. But every patient could have multiple patient histories, multiple patient history records. Okay, so like Sarah here has visit 1 and visit 2, but Mark has only one visit. Ilse has also one visit. So mandatory 1 to mandatory minimum 1. Okay, that's all about the cardinality. This is an example of multiple relationships. So here we have a unary relation. The employee supervises other employees, and also the employee works in a department, and also there's supposed to be another employee who manage the department. Okay, so here we have this one is unary, and this one is binary. This one is also binary. Okay. Strong versus weak entities. So here in this slide, we are talking about the strong entities, weak entities, and identifying relationship. Okay. For the strong entities, exist independently of other types of entities. Okay, as I mentioned in our last scenario, the scenario of city and country, if you remember. Country and city. So the city belongs to country, right? And the city cannot be exist unless the country exists, right? So this one is mandatory, and this one is it could be optional. If let's say it's allowed to have a country without cities, and also if it's not allowed to have a country without cities, then we can make it mandatory. No matter is it's mandatory or optional, it's no matter. This type actually is a weak type, and this type is strong. Why this type is strong and this type is weak? Because it's all about that dependency. Who is depends on the other. So this one depends on the country, right? So that's why this side is weak and this side is strong. Okay. The strong entity has its own unique identifier. Okay, at the country, we have the ID of the country is the primary key. Okay, but here for the city, we will have the city ID and the country ID together. So the primary key of this city table is a combination of two columns, or also it could be only this one is a primary key. It could be this one is only a primary key, but this one supposed to be a foreign key coming from the country. Okay, so this one is coming from the country table. So the existence of this record depends on the existence of the instance of the country at the other side. Okay, here represented with single line rectangle. Okay, the strong entity, as we said, this one is using only a single line rectangle, while this one uses double line rectangle. Okay, because this one is, as I mentioned, weak. Okay, then weak entity depends on a strong entity, cannot exist on its own, does not have a unique identifier, represented with double line rectangle. Then we go back to we go forward to the identifying the relationship. So links strong entities to weak entities. So the relation is used to link the weak entities to the strong entities, and also it's used to represent. It's represented with double line diamond. Okay, let me explain what is this. If this is the country or the city, and this is the country. Okay, which one is strong here? Country, right? So the country will remain single line, and the city is weak, so the city will use double line. And here the relation between these two is a relation between a weak type and strong type that is going to use the double lined diamond. So here we could say located in. So the city is located in the country. So the relation here is one country mandatory that could have multiple cities or no cities inside it. Okay, this is how we can write or we can draw the entity relationship diagram. Okay, okay. Maybe somebody will say why we use double line here. Why we use double line? Because this relation between the city and country is called, let us go back here to remind you here. This relation is an identifying relationship. Because there we have also another type of relationship, which is the normal relationship with a single line diamond. Okay, why this one is called identifying relationship? Because this city, any city, is going to be defined based on the country, right? It's going to be defined based on the country. And also there could be cities with the same name, like Tripoli. There is one in Libya and another one in Lebanon. So here there is Tripoli belongs to Libya and Tripoli belongs to Lebanon. How we can identify which Tripoli is it? So in this case, we have to consider the country ID or the country name. Otherwise, it's going to be confusing, right? And also there is other cities that has the same name. I think there is some cities in the world has the same name, but I really forget. I only remember Tripoli. So if you have any example in mind, you just let me know. Anyone has an example in mind of similar cities with multiple cities with the same name? Okay, no problem. So even one example is enough to explain to you why we call this identifying relationship. So the identifying relationship must have double line. Okay. Okay, another example of the strong and weak entity is the employee and her or his dependents. So the dependent here is identified based on the employee. That's why the employee has a dependent, maybe one dependent or more, or maybe the one employee doesn't have any dependent. But here, every dependent should be defined or identified based on the employee ID, because the dependent is not an employee in the system, and the dependent has no employee ID. So everything in this system is supposed to be linked to the employee ID. That's why it's called identifying relation. Okay, here we have something called associative entity. Okay, let me stop here for today, and tomorrow we complete about the associative. We stopped here. Okay. let us go and open the SQL developer. Okay. This is our today our first practice to deal with the real database. Okay. So everyone, please open the SQL developer. Okay. Are you ready? Are you ready, guys?
Oh,
wait,
not yet.
Already. Okay, let me check what is my username and password. Okay, I'm going to create a new connection. So what I have to do is only to click on the plus button here for the new connection, or maybe I go here. This one is for a new query. So if I click here, it will show me many things. The wizard, the new gallery wizard. So we can create a new database file. We can create database object. We can create connection. We can create deployment profile or XML or whatever. So the connection could be created from here, and later we select is it database connection or subversion repository connection, which one. So if let's say for our example we need to select this, then we click OK, or directly we go and click the plus button. Here we have an arrow beside the plus button. So this arrow shows us three options. The first option is new database connection. The second option is new Oracle no SQL connection, and the third one is new cloud connection. So ours is new database connection. Also here we can click on this new button. This button will show us the same wizard of this button. Okay, so directly we go to this button, click plus, and we will see the new connection wizard. So the first thing we need to do is to create a name for this connection to differentiate between it and other connections. As you can see here at the left side, I have my local database, which is connected to the Oracle server installed on my laptop. But here I want to make it FSKTM database. Okay. Here we have to select Oracle because we don't have any other option. We have only the option of Oracle. And under the user info tab, we have to select many things. The first thing is the authentication type. So in the authentication type, we have default operating system Kerberos. So this default means we will create the username and password here. If based on the operating system, then our username is supposed to be supposed to use the username and password of our Windows, or maybe Macintosh or whatever. And the other option, the third one, is the Kerberos. It depends on, it's based on a Kerberos server. So we have to have a Kerberos server first that has our credential. Then we have to select it. Then after that, we have to give some information here about the credential. Okay, so we will keep it default. Then we put our username. I'm not sure whether it's like this or not. Mohammed. Okay. And my password, I'm not sure. Okay. If you are using your own PC, it's better to save the password if you like. If this PC is not used by anyone else other than you, So you can save your password instead of keying the password every time you want to open your database or you want to create a query file. So it's up to you if you want to save or not. But if you are using a public or shared PC, then you never save your password. Okay? The rule here, we have multiple rules: default, system DBA, system operator, system backup, and so on. So which one we use, we keep the default. Okay? Then after that, we have the proxy user tab. We don't go here. We just fill up the information here in the user info, because this one is depends on a proxy authentication. So we have to have a proxy that saves our credential. Then we have to provide the information for the proxy. Okay, here the connection type is basic, cloud wallet, custom JDBC, local, LDAP, SSH, TNS. So ours is basic. Under this, we have details and advanced. So what we are going to do is only the details here. We are not going to do anything in the advanced. However, in the advanced, we can add here some things, which is name and value. It depends on what kind of advanced settings that we want to do. Okay, for here, we have to decide or we have to determine the host name or the IP. If let's say we have a host name like, for example, like this, Google, for example, .com, here, for example, DB, for example, like this. If let's say the host name is something like that, then we could use the host name. Otherwise, we have to put the IP address. And the port number is 15 to 1, which is the default port number. This one actually is depends on what port number we have used when we install the Oracle server. So if let's say during the installation of the Oracle server we changed the port number to, for example, 3500, then we have to use 3500. Otherwise, it's not going to be connected. So here for the SID is also the SID that we provide during the installation, FSKTM. Okay, it's up to you to use the SID or to use the service name. So for our case, we are going to use the SID because this is the only information that's given by the system admin. Okay, after we finish, we click test. So if the server is up, then it will show us success. Otherwise, it's going to fail. I think it's not going to work. We are not sure about the server. Is it up or not? So for this reason, I'm going to ping the server to see either the server is there or not. Actually, the server is not available. You see, when we ping the server, request timeout. That means the server is down. So we cannot work in the server for now. We cannot work on the server for now. Okay. What's about you guys? Oh, it works. Success. It works finally. So why it doesn't respond? Maybe they stopped the ping response at their firewall in UPM there, so we cannot rely on the ping anymore. Okay, the status here is success, so we can create the connection. Okay, the connection is already created, as you can see here. Let us click on the plus button beside our connection to drop down the components of the connection. it's very slow because it's working on the remote database, and it looks like the network is not stable. Okay, to save time, guys, to save time, I'm not going to work on the UBM server. I'm going to use my own. Okay, because this one actually is very, very slow. You can see here it's still loading. It takes long time, and it will waste our worthy time. Okay, let me go to the local, my local database. Okay, and here we have here multiple things under our database. So this one actually shows the system tables here because this one is my own. I am the system admin of this database server. That's why I can see the tables. Okay. Anyway, if for example I'm going to create, if I want to create a new table here, I have to go to the tables folder. I have to go to the tables folder, right click on the tables folder, then I click new table, new table. So here it will show us the scheme. The scheme, there are many schemes. The default one is the system because our user actually is a system admin. Okay, our user is the system itself. We logged in here for the local DB using the system and system as a username and the password together. So here the table name, for example, we want to make it employees. So here the best practice for creating tables is to use plural names. But for the entity relationship diagram, the entity should be represented by a singular name. It's only a singular name in the entity relationship. But when we come here to the database and we want to create the table, then the table must be in plural because the table will include multiple employees, right? So the name should reflect the contents. And every record should be an only one employee. Okay, this is the table name. Then after that, here we have columns. So the first column, we can make it ID. ID. The type, for example, is number. Size is up to you if you want to put the size or not. Here it's ticked, not null. We don't want to allow null here for this ID because we don't want to have an employee without ID. Default value here is up to you if you want to put default value, and here is the comment. So this one is the employee ID. Okay, if you want to write the comment, it's up to you. Otherwise you can keep it empty. Then we go here, for example, we create name. Name could be created as a full name in one field, or could be created as first name, and the type is varchar2. The size is 20. Varchar2 means characters. It could accept numbers, letters, and special characters. So the size of the first name is 20 here, or even if you don't want to make it 20, if you want, for example, to make it 30 or maybe 10 only, it's up to you. Then is it allowed to be null? No. Default, we don't have default. Here is the name. I don't want to write the name. I don't want to write any comment. Then here later we want to create another column, which is the last name. Varchar2 is also 30, not null. And for example, we go here and create, for example, the address. varchar 2, maybe the address is 100 character and not null for sure, because the address is very important as well. And here we could have, for example, the manager ID. So the manager ID could be null because the top manager shouldn't have a manager ID for him. Okay, so this one we will keep to allow null. Okay, this is the boss ID. Okay, okay, this is the table now. So now for this field we make it primary key. For this field we make it primary key, and for this field is not a primary key, but we want to make advanced here, and identity column index constraint. This one is primary key. Let's go to the constraints here. Okay, this one is the primary key constraint, and let us go back to the columns. Let's remove this. Constraints is like this. So we have one constraint for the primary key, which includes only the what they call it, the name of the relation, the name of the constraint. Okay, let us create another constraint. The other constraint is a new foreign key constraint. We need to create a foreign key for the for what they call it, the employee underscore manager foreign key. We have to use a very descriptive names. So here in the foreign key name we have to mention the names of the two sides of the relation. So employee and manager foreign key. Here the scheme is system, the table is here, the table is employee, constraint is here, employee. This is the constraint. Okay, the primary key. So the local column is ID and the referenced column is what? I don't know why it's very complicated here. So this one's supposed to be what they call it, the manager ID. Oh, this one is the referenced constraint. Referenced constraint. Ah, yes. Referenced constraint, and this one is the local column. Local column supposed to be the manager ID. Okay. Anyway, it looks like we have to create something here first. This one is primary key. How we can change this? System, employee, number, columns. Okay, columns to table employee. Find constraint. Okay, constraints is here. So constraint name is this one. So primary key. I don't know why they changed it. Anyway, we are going to learn later how to create this. Indexes, memory, storage, partitions, comment, and DLL. Okay, don't worry about it. So now the concept is like this. Okay, if we want to click OK, then the table is going to be created here. So this is the table, and here is the description of the table, as you can see here. Okay, this one actually is the primary key, and this one is not set for foreign key yet. Okay, let us close this. Let us go here to see the how to use queries. Describe employee. Describe employees. Oh. So if we run describe employee here, this command, the employee is the table name, and the describe is to show the description of the table. Here we can see the information about any table. Okay, let us go and edit this. I don't know why the primary key is not showing here. The information about the primary key is not showing. Anyway, so if let's say we want to insert data, insert into employees values, and we open like this. So what values we want to insert? If let's say we want to insert number 1 for the employee number, and the name is, for example, Ali Ahmed. So as you can see here, the name should be put between two quotation marks. And sorry, this one is Ali, the first name, and the last name is Ahmed. Then the address, for example, is maybe UPM Bank. Then after that, the manager ID is 0, null. Okay, so if we run this, error at command line 1. So what is the error? Column not allowed here. Okay, maybe I forget the insert command. Insert command Oracle, because I confuse sometimes. I use too many types of databases. That's why I confuse which one belongs to which one. Anyway, because the Oracle deals with something called BLSQL, then the insert statement could have something different. So we used insert into table, then columns, values, followed by the values. For columns, we didn't put because we followed the exact sequence of columns. The exact sequence of columns here. We did not change. That's why the what they call it, the columns is not used here. But this is not the issue. It's not the issue, I'm sure. Is it single? Maybe single. I think it's single, yes. It's very important to remember, is it single or double? As I mentioned, because I use many types of databases, that's why I always confuse which one is single or which one is double. cannot insert null into manager ID. Okay. Why cannot insert null? Because maybe we did, oh, you see here we make it mandatory. That's why we cannot insert null. So here we make it null, then we run. Okay, one row is inserted. One row is inserted. Okay, if let's say we want to show the data, select, we want to show all data inside the table, we write select star means everything. Select star from employees. So this, we select only this and we run to implement the selected code only, because we don't want to run the insert command again. So here, as you can see, we have one record. Okay, if let's say we want to insert another employee, so here the name is Khalid, and here Mustafa, and also UPM Serdang. Let us run this. One row is inserted, then we run the select star command again, then we see Ali and Khalid here. So two people are inserted into our database. Okay, so this is how to create the table and how to insert the data, how to retrieve the data. This is only a brief explanation about the tables and how to deal with it, in order to prepare you for the coming practice and coming scenarios that we are going to create. Okay. Anyone has a question about this? Any question?
No for now, Doctor.
No for now. Is it clear for today? Is it clear, guys?
Doctor,
Yes.
I still cannot insert the values.
You cannot insert the values.
Yeah.
Okay, what you have done?
So far I've done the insert into employees. Yeah, the upper one, but it doesn't like print the names, like the strings, right, into blue. It's still black. I don't know why.
Still black.
Yeah.
So maybe you missed something. Is the word insert is blue and the into is blue, also the value is blue? Are you sure? Because if let's say you forget if you forget, for example, the s of values, it's going to show you an error. And also if the table name is wrong, it's going to show you an error. So make sure that everything is correct, because the SQL commands is very sensitive.
Only the ones with the word, the sentence. The value like one and the null, it's already in blue.
The one and null is in blue.
Yeah.
Yeah, it's supposed to be okay. Supposed to be okay. It depends on the style of your editor. Maybe in your editor you are not using the highlighting theme to make it blue. Don't worry about it. Just run the command, or if it doesn't run, just paste it in the WhatsApp group. I want to see it.
Okay. Also, doctor, the attendance we cannot take.
All of you cannot take the attendance? Is it all of you or only this student only?
Yes.
Yeah, I
Yes.
cannot take.
Yeah.
All of us.
Okay. Okay, then okay, let me see what happens for your command first, then after that we handle the attendance. Don't worry about it. Is it working or not? Anyone got an error? Anyone got an error for the insert command? Hello? Anyone has error?
I'm still trying, Doctor.
Still trying. If you have any question, any difficulty, please ask me. Open your mic and ask me, because for today we are almost finished, and inshallah for tomorrow we are going to continue with our slides until we finish this part. Then we will start dealing with the modelings and how to create the entity relationship diagrams. Okay, I'm going to finish the this class of today. I will stop recording, but I will continue with you if you still have some difficulties or some questions. I will stop only the recording. Thank you for attending my class of today, and see you inshallah for next class.